I'm Rinku Dhiman, working as an assistant professor in electrical engineering department at RPIIT Technical and Medical Campus, Karnal. So today we are going to discuss fundamental of digital signal processing, that is also called DSP. So these are our presentation outline. So we are going to discuss this topic today. The first one is your introduction to DSP. The second is your principle and operation of DSP. And third is advantages and disadvantages of DSP application. And finally, we will make a conclusion that we have discussed over here. So one by one, we will discuss all these things in further slides. So first of all, before going through the subject, we must understand what is signal. So we must answer like that: any physical phenomenon that carries or convey information from one place to other and represent as a function of independent variables such as times, distance, space, etc. So here is the example given like that. We are given with a ES signal with respect to time t. So this is our analog signal which have some amplitude at a particular time t. So we can say that this is an analog signal. So what is signal processing? Signal processing is the analysis, interpretation and manipulation of like sound, images, time varying measurement, values and sensor data, etc. Types of signal processing include two types. The one is your analog signal processing and another is your digital signal processing. So here analog signal processing is represented by this representation and digital signal processing by representation by this representation. So analog signal is nothing but it is continuous in nature like this. And in digital processing, every signal have discrete value at a particular time. So these are the linings given like that. So these are nothing but the discrete value at a particular time. Digital signal processing include three terms. One is your digital, another is your signal, and third is your processing. So simply digital means we are dealing with the number system. So either 0 or 1. Secondly, signal, it is already discussed like a parameter that can be varied in such a way as to convey informations. It may be electrical quantity, so can be analog or digital kind of signal. Then third is processing. It is a series operation performed according to programmed instructions. So basically, this whole block diagram represent a digital signal processing process. So we are here with that is information input signal. That is our analog signal. Basically, we fed this signal to ADC, that is analog to digital conversion block, which convert this analog signal into digital signal. And so we are here with digital signal at this point. This digital signal is processed by the digital signal processor or some computer based algorithms. Then we get a signal, digital signal over here. Then this digital signal will fed to DAC, that is digital to analog conversion. So we will get over here analog signal, and this analog signal will fed to the audio amplifier, which amplify the signal, and amplification output will send to the speaker. So we will get a speech signal over as an output. So this is the whole process for the digital signal processing. So what is the need of this signal processing? So basically we are with input signal like this. This is our information signal ES with respect to time t. This is nothing but an analog format, pure analog signal, we can say that. But when we feed this signal to our signal processing system, some environmental distortion will be added on this. So this distortion will change the magnitude of our analog signal. So we can see that our analog signal is like that, but our distortion added signal become like this one. So here is the distortion, here is the distortion, we can say that. So this will change change the magnitude of our input signal. So this distorted signal we fed to the signal processing. In signal processing, number of filtering operations, number of algorithm based technologies we are using. So our finally signal will be like that, which we fed as the input signal, and we will get the same at the output signal. So this is the need of signal processing actually. And the basic principal operation for DSP is like that. Already discussed that the pictorial view is given like that. So it includes the number of factors like anti-aliasing filters, ADC, that is analog to digital conversion, digital processor, DAC, digital to analog conversion, and a reconstruction filter. So simply this is a microphone. We fed the information signal over here like our space signal. We will amplify this signal. Amplify means it including the pre-aliasing filter and all that. Then we will fed this signal to A to D converter, which convert the analog signal into digital signal. Then we will fed that signal to our digital processor. In digital processor, we process the signal based on computer algorithm. And finally, the digital signal fed to D to A converter, and which convert the digital signal into analog signal. And this analog signal fed to our speaker, from where we will get the some output in terms of voice. So this is the basic principle of operation of DSP. So the main concern in DSP is our filters design basically. So two kind of filter we using in signal processing. One is your digital filter, another analog filters. And further, digital filter are classified in two categories, FIR and IIR. So FIR represent our finite impulse response filter, and IIR represent our infinite impulse response filter. So the main two reason is there for which we are using filters basically. One is your signal suppression, and another is your signal distortions. Signal suppression is related to that we will separate our signal from the distorted one, and in signal distortion we include that we will reconstruct our signal after sampling process. For example, like an audio recording made with poor equipment may be filtered to get the original sound. Another example is like that deblurring of an image occurred with an improperly focused lens or a shaky camera, we can say that. So these problems can be solved by either using analog or digital filters. Here an example is given like analog filter is this one and digital filter is this one. So we are using over here RC filter basically. So we are giving the input analog input over here, distorted analog input over here, and we will get the perfect analog signal as an output of this filter. Simply in digital filter, it is a combination of adder, say multiplier, delayer. So this is the combination of these components. So we are giving the analog, digital signal over here, distorted signal, we can say that, and we will get the filter signal as an output. So this is all about the filter section. The digital filter basically perform these two main, like it will generate the digital signal and will process that like in terms of digital data, and it will include the components like adder, multiplier, delay units. So simply digital filter have a vastly superior in the level of performance in comparison to analog filters. So that's why we are preferring nowadays digital filter in comparison to analog filters. So these are the advantages of our DSP filters in comparison to analog filter, because they immune the environmental changes. They are designed like that in any kind of environment. They will give a filtered signal basically, and they have very less noise and relatively stable in comparison to analog filter. Impedance matching is somewhat is a technical advantage over the analog filters. Then another is the computational problem is resolved over here. In analog filter, we have to make like a slow computation process, and it will include the manual operations basically. In computation, we just put an algorithm and all the arithmetic operation like multiplication, division, subtraction have done in nanoseconds. Second, the availability of multiple filtering is there in DSP. Variety of shape and amplitude and phase responses we can achieve using our simulation process in DSP. And similarly, easy transportation and reconfiguration is we can done over there. So this is the one of the advantage of DSP, because we are using the reconfiguration process again and again in DSP, because everything is done on our algorithm based. Otherwise, in analog filters, if we construct analog filter basis on electronic component, so we can't change it. So that is the main advantage of DSP filters. Advantages of DSP digital signal processing are main advantage like it give accuracy. So everything is based on computer algorithm. We get maximum accuracy in this processing. Flexibility is there, easy operations, and the multiplexing of signal is done very easily. And one of the most important advantage, storageable capacity it have very much high. So we can store our data in the past input. We can store on the basis of that past input. We can check our system for the future one. Now, the application of DSP includes the image processing and consumer applications, cellular mobile phones, in communication system, in speech and music, in biomedical instrument, in radar and sonar kind of equipment. So all these are application of our DSP. And there are also limitation for DSP. One of the important limitation is like anti-aliasing filters. Basically, in digital signal processing, we convert the analog signal into digital signal. So that is basically sampling process. In sampling process, there is like a aliasing problem over there. Overlapping of signal is over there. So the thing is that our high frequency signal cover up the low frequency signal. So information is missed over there. So anti-aliasing filters are used to overcome these problems. Then frequency resolution is the main concern in digital signal processing. So this is the main disadvantage in and nowadays this is the most important research area in DSP. Quantization error. Quantization error is related to our again sample and hold kind of information. At some point there will be some errors in quantization process of sampling. So that is the limitation of our DSP. And finally, we make a conclusion of all these discussions. Like DSP is a series of instructions to manipulate the digital numbers basically. The second, DSP is in wide range of everyday applications. Digital signal processing is often used in modern audio logical equipments, and digital signal processing gives the wide variety of storage capability in comparison to analog filters. So again, we can make our predictable system based on our past input or past experiences. So storage capability plays a very important role in that case. Finally, this is all about the DSP fundamentals. Thank you very much. Stay tuned with us.